Hello, YouTube. This is Mr. Bakari. Today we are going to graph sine and cosine functions with a period change. So I encourage you, if you have not already looked at my introductory to graphing sine and cosine, watch that video first and then come back and join us here. All right, what is a period change? So a period change is basically you take the period of a graph, which is 4 steps, basic length of the wave or trig graph, and you either horizontally stretch it or compress it to where the period changes in size. Okay? So before we get to that, for every problem, let's review what are the steps that we go through. So step number one is we find the midline. The midline is your vertical shift. Okay. So the midline starts at y equals 0, and the vertical shift, wherever that takes you, you move the midline. Now you find the high and the low lines, which is the amplitude for the midline. So that's your vertical stretch or compression. Okay, so we find the x value where we start, which is determined by our horizontal shift. So if there is no horizontal shift, you simply start at 0. Okay, now the period change, well, the period of cosine and sine is 2 pi to begin with. But if there is a horizontal stretch or compression, which is represented by the letter B, typically in a transformational form that is being shown, then what we need to do is to divide our period 2 pi by b, by the value b. And that's what we're going to look at today. After that, we're going to find our steps, and that is always to take your period, wherever that might be, and divide it by 4. And then lastly, you want to make sure, is this function has it been reflected? If it's been reflected, then you need to reflect the graph. All right, let's look at an example. Here's our example. This is a cosine graph. And if you look in parentheses, we need to factor this. Okay, this is a bit misleading as is. So if we factor out the 4 here, you can see that our horizontal shift is actually left pi over 3. Okay, go ahead and distribute that back and make sure you get what you started with. So our start is negative pi over 3. Okay. Now our period is 2 pi, of course, but there is that b value right here. It can be found between the function name and x right here. So that is our b value. So what we're going to do is we're going to take 2 pi divided by b. So 2 pi divided by 4, which will give us pi over 2. So as you can see, if our period was 2 pi and now it's pi over 2, it's been horizontally compressed. So something to keep in mind is when b is greater than 1, that's going to be a horizontal compression. And if b is between 0 and 1, that will be a horizontal stretch. Okay. Now our step is always found by dividing our period by 4, which is going to be pi over 8. Okay. Like I've said previously, in graphing these kinds of functions, you want your step and your start to have a common denominator. So the common denominator there is 24. So what I'm going to do is I'm going to change that to 3 pi over 24 and negative 8 pi over 24. Okay, so now I have a common denominator, and it's going to make graphing this thing a lot easier. Okay, I'm just going to shrink this down a little bit. All right, let's look at our midline. Our midline is on the y-axis. sorry, the x-axis at y equals 0, unless the graph has been shifted vertically, which this one has. So we're going to go ahead and shift that down 1 because that's what it says to do right here in the function. And then we're going to establish our high line, which we look at our amplitude. So as you can see, our amplitude is 2. So I'm going to go 2 above my midline and 2 below my midline. And that establishes the height of the sine wave or cosine wave. Okay, I'm going to write those y values to the left over here. That's y equals 1, -1, and -3. This establishes your vertical shift and your amplitude. Okay, can be seen right here. Now I'm going to go ahead and label my x-axis. And as you can see, our start is at -8 pi over 24. Now, if my step is 3 pi over 24, I need to leave some room here. -8 pi over 24. And then I jump 3 to -5 pi over 24. I jump 3 to -2 pi over 24. Jump over the origin there, and I'm at pi over 24. And one more step will bring me to 4 pi over 24. Okay, that's 4 steps. That is 1 period. Now, let's check. Our period, as you can see over here, should be pi over 2. So the distance from here to here should be pi over 2. And -8 pi over 24 to 4 pi over 24 is a difference of 12 pi over 24, which is indeed pi over 2. So we're good. All right. So this is a cosine graph, which starts high typically, but it's been reflected. So this is going to start low. Go to our midline, our high line, midline, back to our low line. We'll connect these, and there is 1 period of cosine. I always like to circle my starting point. And when I circle my starting point, I can clearly see this has been shifted over, right? Pi over 3, which is -8 pi 24. As you can see over here to the left, it's been shifted down 1. And we can see from here to here, our amplitude is 2. And again, from here to here, amplitude is 2. That looks good. And we are finished. There you go. Easy as that. Now let's look at another one. This is a sine graph. Okay. So first, our sine period is 2 pi, but again, we do have a horizontal compression, stretch. Let's see. We're going to take 2 pi and we're going to divide it by b. So if you take 2 pi and divide it by 2, you get pi. So what does that mean? Well, the period was 2 pi. Now it's pi. It's been horizontally compressed. Okay, so take our period, divide it by 4, and we have our step, which is pi over 4. Our start is our horizontal shift, which would be x equals pi over 6. Of course, I want a common denominator between my step and my start. It's going to make it a lot easier to label my x-axis. So 4 and 6, we've got a common denominator of 12. So pi over 4 is 3 pi over 12. Pi over 6 is 2 pi over 12. There we go. Okay, so there's our start, there's our step. We got a common denominator. We're ready to bring in our midline. Okay, we always start at y equals 0. And do we have any vertical shift? No, so that remains at 0. Our high line is our amplitude. Well, our amplitude is 1. Look in front of sine. There's our a value. It is 1, apparently. So our amplitude remains 1. So that's going to be easy. That's 0, 1, and -1. Okay? Now, This is a sine graph. So before I get to that, let me label the x-axis. I'm going to start at 2 pi over 12. 2 pi over 12 is right here. 2 pi over 12. This time I'm going to graph two periods. So if the instruction says graph one period to the right and one period to the left, that's exactly what I'm going to do here. So I'm going to go 4 steps to the right. 1, 2, 3, 4, and 4 steps to the left. 1, 2, 3, 4. And my steps are 3 pi over 12. So that would be 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12. Now, when I go the other direction, my step is 3 pi over 12. So that brings me over the y-axis, and my next step is at negative pi over 12. Negative 4 pi over 12, negative 7 pi over 12, and negative 11 pi over 12. Now, with a quick check, once again, if we go from our start to the end, either direction, that should be pi. And sure enough, 2 pi over 12 to 14 pi over 12 is pi. So we're good. Okay, the labeling is probably the toughest part of this. Getting your angles labeled correctly. Okay, so this is a sine graph. So I'm going to start in the midline, 2 pi over 12. And it has not been reflected. So from mid, I go high, mid, low, mid. It's important before you start that you know the shape of your sine and your cosine function. It's very important. Just like knowing all your parent function shapes. Okay, connect the dots. Circle our starting point. And we are golden. Okay? And that is graphing sine and cosine with a period change. Hope to see you next time. Until then, take care.